All right, so in the last video, we learned that some compounds form, some atoms combine together by having these charges. Something like lithium might have a positive charge, and that would stick to an atom like chloride if it had a negative charge. These two ions, positive and negative ions, would stick together almost like a magnet. And this can happen repeatedly. So another lithium might stick over here, and then another chloride, etc. But how did I know that lithium wanted to form a positive one and chloride a negative one? Well, you can see that looking at the electron configurations and understanding the octet rule. So we knew that chloride had 7 electrons in its outer shell, and so it just wanted to gain 1 extra electron to give it 8. But there's an easier way just looking at your periodic table, because your periodic table is organized by number of valence electrons. This first column has 1 outer shell electron. Second column, 2 outer shell electrons. Third column, 3 outer shell electrons, etc. So you can actually just go through your periodic table and easily write down what the charge will be if an element in that column forms an ion. So something in the first column, if it forms an ion, will form a positive 1 ion. Something in the second column, if it forms an ion, will form a positive 2 ion. 13th column, if it forms an ion, will form a positive 3. Then starting at the other side, 17, if it forms an ion, will form a negative 1. 16, negative 2, 15, negative 3. And again, that's just like what we saw in the previous video. Chlorine wants to gain 1 electron, so that 1 extra electron gives it a negative charge. These things, like oxygen, have 6 outer shell electrons, so they want to gain 2 electrons. Those 2 extra electrons are negatively charged, so they give it a negative 2 overall, etc. So that's basically it. There's one big missing section, or one big thing I didn't mention here in the middle, and they're all positively charged, but you don't know what exact charge they are. So we call these transition metals, or type 2, as opposed to the type 1 metals over here. We call these ones type 2 because they have that variable charge. We don't know right off what charge they are. They can be different things. For example, sometimes iron is a positive 2 and sometimes it's a positive 3. So that'll be a discussion for a different module here in a second. For now, just know that they can change. There's some different options. There's one last little thing. These two are what we call type 2 cations, meaning everything in this column, when it forms an ion, will be positive 1. I'm sorry, these are type 1 cations. Everything here, if it forms an ion, will be positive 1. Everything here, if it forms an ion, will be positive 2. These are type 2, which means we don't know. But there's one extra little group that we call type 1 over here, and you can draw a little triangle here. These ones aren't variable like the other ones in this section. These ones, it's pretty straightforward. The things in this column follow exactly what their column you would expect it to be. So these are 3 positives. These 2, now you can just count back. If those are 3 positive, these 2 are 2 positive. And then going back from there is a 1 positive. So these are known, and this little triangle over here is known charges. The ones in the middle are positively charged, but we don't know exactly how much positively charged. The last thing I haven't discussed is this column here, 14. So 14 rarely gets involved in ionic bonding. It usually does the covalent bonding. So I usually just don't label that column entirely. Some people label it positive 4 or negative 4, because when it does get involved in bonding, it usually takes those charges. But that's not really something we have to solve right now, because it rarely gets involved in ionic bonding to begin with anyway. All right, so let's do the activity, and we'll pick up here with the next video.